Today we'll be covering on how to configure your post processor. It's going to be a relative short webinar, so it won't be taking up too much of your time. So let's step right into it. So when you've opened EnRoute, for this one we're using the 6.1.0.20 build, and we're running the complete subscription. So to set up your post processor, you would first have to step into the setup menu and then choose machine setup. So here we'll be using the CR Untitled driver I recently created. And as you can see in this window, you can step through multiple tabs, let's say. So if you're setting up the driver initially, it will have the first driver in our driver list selected. Changing that driver, you can go to the active drivers and then choose amongst all of the available drivers. So once you go to a brand, you can just select one of these models, and then that will be added here in the list. And so when I'm outputting, I'll be able to choose between all of the active drivers I have in this list. So let's just continue with the one I had selected. So the first drop-down menu here, you'll be able to see the driver name and the model and a description as well. So as you can see, you won't be able to edit those here. In most cases, I would advise against editing these, because sometimes the post processor uses the name to output certain code for a specific model. In the second drop-down menu, you'll see the driver parameters. So here you can enter the width, height of your machine. The width is, in most cases, going to be the x-axis. So if you have a feeding belt, that's typically the way it moves. It's typically over the x-axis. And then actually the most important setting for this is going to be the Z-lift. So this is going to be the safety to which the spindle is lifted when the machine is moving over the plate itself. So I would say 5 to 10 millimeters should be enough for it to travel safely. And it should cover the discrepancies in the height of the material. So if the material is a bit wavy, this is to make sure that the tool does not hit the material while moving. So next we have the home position. As you can see, the home position can be set to the plate, to the design, or your selection. Typically, it's set to user, or by default, it's set to user defined, which means that none of your design or settings here will interfere with the origin of your machine. I would leave it to user defined by default. So next up would be the tool changer. For this machine, we have 12 tools available. And you, of course, also have the possibility to toggle this off if your machine does not have a tool changer. So if you have a tool changer selected, you can simply click to edit. And then here you can choose between all of the available tools that you have set up through the tool library. So if you choose to remove tool, you'll notice that it's actually removing the amount of tools in your spindle. Here you have an additional one to empty the complete turret and reset up everything according to how it's reflected in your device. Then if you have a tool missing, you can go to Setup, Tool Library, and here create new tools as we've seen in a previous webinar. So let's go back to Machine Setup Next up would be our drill bank. So some machines have a special unit to make drillings for cabinets, and that can be set up in here. So this is a typical layout for your drilling unit. So often it's in an L shape, could be differently oriented. So important one to notice is that drill number 1 is going to be the origin for your drill bank. So the way EnRoute outputs it to the G code is going to be by pointing with drill number 1 here. Drill number 1 can also be placed in the corner, and then it could go like upwards 1, 2, 3, 4, 5, and then 6, 7, 8, 9, for example. And in this case, you can also, so here you control the number of drills. Typically, the distance between the drills is going to be 32 millimeters. For this one, we'll just put this on 160. This one as well. And as you can see here, you can also define the direction of the drills. So all of these drills are going to drill into the Z negative. But for this one, for example, we could position it into the Y positive and the Y negative. So this would mean that the machine has an aggregate to drill into the sides of the material. And then, of course, like the tool changer, here you'll be able to select all of the drills that you've set up in your tool library to match the configuration that you have on the drill bank itself. Next up are the driver speeds. So these will be the default speeds that the machine will use. So if you create a toolpath and you do not assign any feed rates or spindle speeds, then it's going to be using the one that you have specified in here. So for example, for the spindle speed, put to a default of 16,000. The feed rate within the material, you can set up the default, the maximum, and the minimum feed rate. Usually I just set up the defaults, so I'll go to 4,000 per minute here and 2,000 per minute here. The dwell is more of a legacy option, which is no longer used in the current machines. This would mean that it would give your machine a certain amount of time to get the spindle running up to the specified speed. Above the feed rate, above the material feed rates, I typically do not set up here, because when the machine is moving at above the material, typically it uses the fast repositioning command, which means that it will travel at the maximum speed for your machine. So for these, I would only set up the feed rates within the material. Next up are the driver units. Also very important. Depending on which units your machine expects, you would have to specify those here. And then based on the settings here, EnRoute will output the values for the G code according to what you've set up here. Communication parameters are, these are actually also for the older machines that use a COM port, one of these ports. All of those settings you can set up here according to how it's set up in your device manager. So those settings would have to be reflected in here. But typically for current machines, you'll be outputting to a file and then delivering that file to your machine's controller. In the advanced parameters then, we'll see the machine resolution here. This is not going to be used for every machine. Typically, if you're running HPGL drivers, it's going to be using the machine resolution set up here. You also have settings that you can modify regarding the arcs that are used or described in the G code. And then, of course, you can specify if your machine can make use of arcs, if your controller understands those. If you uncheck these, then every arc is going to be output as or every arc is going to be split into many small lines. And then this final one, you can set up if your this has drill function, for example, is used for the CIX driver. So this one doesn't really use the drill bank because it's those files are often imported into the bsolid or BSEworks software. And for that driver, it's simply necessary to use the drill function instead of using the drill bank, because the drills are going to be selected in the control software for the machine. So those are actually most of the parameters that you can set up for each driver. If you have any questions regarding any of those, please feel free to ask, or if you have any other questions